All right, let's look at how to do a multi-stage analysis in LS-Dyna using the case command and the Dynain files. What I'm going to do today, I'm going to share an example model that I've already prepared. The goal here isn't to focus on how to set up the model like this, but it's to look at how to set up a multi-stage analysis once you have a model built like this, right? How do you split the main model into different stages to do a multi-stage analysis? What I'm going to talk about is also the general idea behind why the case command works with the Dynain files. What's the value for doing something like this? And why do you want to do it, right? And then lastly, I'm going to do a quick demonstration of some of the key steps in setting it up once we have the model ready. How do you do the split to generate a multi-stage analysis? Okay, so what we're gonna do today, in terms of the model, is I'm gonna do something like this, right? So this is what you've already seen in the model. Basically, what I have here is a plate that's sitting on 2 foot. The way the plate is fixed on the foot is through these 4 different bolts, right? Now what you're seeing here, this is essentially like a point mass that's attached to the center of the plate. Imagine this thing has a giant, mass sitting on top of it, right? And then what I've done in the model is I've converted the point mass into this. I think this is something like a few 100 pounds, I believe. Oh, it's only like a 40 pounds actually, but this thing is pretty small. If you want to look at a scale, I think you can look down here. This is only about, maybe 8 inches by 8 inches of a plate, and it's holding about a 40-pound weight. And then, the model itself is set such that, you essentially have what you expect the bolt to be. Basically, there's a friction between these set of plates. There's a sort of like a bonded contact, tight contact between the nuts and the bolts. And then everything else is going to be a frictional contact, like an automatic contact, right? So you can sort of see the way I have it set it up, right? The only places where we have tight contact is between the nuts and the bolts, right? Everything else is going to be an automatic contact or a frictional contact or sliding contact between everything else. So what I wanted to do here is that we're gonna apply a bolt preload, which is going to tighten the plates together. I'm then going to apply a gravity, which is going to basically just put this under the static condition of having gravity acting on it. And then what I'm going to do from that point forward is to apply an acceleration that's going to be greater than gravity in the x, y, and z directions, right? So in that case, I wanted to see, based on the arbitrary bolt preload that I've applied to the to the to the 4 bolts, is it going to hold up against the arbitrary acceleration load that I generated? Remember, I have no idea. I didn't design anything. I just made up some real numbers, some actual numbers, and then I don't know how the plate is going to respond. I'm just putting it together and see what happens, right? And the idea here isn't to build a model like this. The idea here is to demonstrate how to do a multi-stage analysis. Okay, now you might think, okay, so what's the value? What is the multi-stage analysis, and why do I want to do it, right? So in a problem like this, right? So you can sort of imagine, usually what you would do is that you would do the bolt preload first, then you apply a gravity load, then you apply the acceleration, like in a sequential stage. So this will be one model, this will be another model, and this will be another model. So you have to run 3 separate models to analyze these 5 different situations together, right? Basically, I want to be able to put my structure together in stage 1 and stage 2. Then I have to exert 3 different accelerations on that structure in 3 different analysis. So what Dynain and what case file allow you to do is to be able to run 3 different models with 5 different stages in essentially a single job submissions, right? So within that single job submission, I'm gonna be able to run all 5 of these analysis in 3 different sequential analysis all in one, and I'm gonna be able to evaluate results in stage 1, in stage 2, as well in stage X, Y, Z direction acceleration. So I'm able to look at the post processing in all 5 of these stages, and then I'm able to basically run all those analysis in a single job submission. So once I click solve, it just goes. You will solve all 5. right? So you can imagine something like this will be very valuable if you have a very large, say for example, DOE you want to do, right? You can basically click the solve button and it's gonna run say 64 runs all in a single go without you ever having to look at it, and then you will have results for each of those 64 runs. And that's the value of using case model of using case command in LS-Dyna, is that it essentially allows you to set up a lot of different things like parametric studies, DOEs, or even a simple example like this with a single job submission and you're done, right? And that's the value that we're trying to demonstrate with this thing. Okay. Now, before I go to the actual demonstration, right, a few key things to talk about. Um, the bolt preload that's created inside LS-Dyna, right? This is very similar to Ansys Mechanical. What happens usually is that you actually split the bolt in half, attaching a rigid element, which is usually what happens inside the Ansys Mechanical package. What happens in LS-Dyna is that you actually generate something called a database cross-section plane, and this is the plane that you are going to define inside the preprocessor to cut your bolt, right? So the first thing we do is that we have to define the cross-section plane, and that's what we need to do. Once you have that, the initial stress section card is going to define the pre-stress based on the location of the cross-section plane that we're generating, right? So when we're doing a bolt preload, what we're essentially doing is define a plane, then define a pre-stress on that in that plane so that it ties the bolts together. Very much similar to Ansys Mechanical, right? But it's a little bit more nuanced in Ansys than Mechanical, right? So what we're doing here is that with this card, with the database cross-section, we're defining a plane that looks like this, and this is the actual view that's inside LS prep post. If you go down a little bit more, so what happens inside Workbench is that I have to create these coordinate systems, right? So if you look at my coordinate systems, right here, right? I've defined these 4 different coordinate systems. Now notice the XY plane has to be the plane of the cross section. The Z plane, the Z axis can be whatever, but the XY plane defines the location of your plane, right? So what I did was I created 4 different coordinate system. Each of those coordinate system has origin located in the center of the cylinder, and it has XY plane existing along the plane of cross sections. And that's how I'm defining the database cross section, right? And then within the bolt pretension object, I can actually define the pre-stress that's going to be applied to the bolt. Now the value I'm using here is basically arbitrary, right? I didn't calculate anything, I just used a number, and then that's what I'm going to do. Okay, that's the first thing to know, right? So remember, when we're doing bolt preload inside Dyna, we're generating these 2 cards, which are very critical to the responses that we're trying to to the creation of the bolt preloads. All right. The next thing to know is that I have a point mass assigned here, right? Now this point mass, the acceleration that's generated on that point mass is done through these keyword, which is a boundary prescribed motion node. So what I'm doing essentially here is to apply a set acceleration on that node. Now this node 13633, right? So you can ask like, how do I know what is the node number of this remote point? That usually you can't really find out what that is. So what I use is a script that I wrote to basically find the node. So what I usually do here is I will go to my node find, and then I will copy this over, right? So what I usually do is do this, and then bam, you see this 13633. That's basically what allows me to find the remote point, and that's 13633 is what I use inside my key card right here to generate the acceleration that I'm looking for. I'm basically generating a triangular function of accelerations, or trapezoidal, whatever you say. It's a pretty big acceleration that I'm generating, and then I'm gonna essentially hitting it against the plate, right? And that's what I'm doing. So this script right here is what I'm using to find the node number, and then I'm using that node number to use a boundary prescribed motion node, and then and the constraint node rigid body is what ties that node to all the nodes that's in the red surface, right? And the element inertia is assigned to this node number. You see the 13633 is assigned with the element inertia, which is what gives mass to that node, and that's what allow you to do a point mass, right? Now this level of detail is very important to understand in Dyna, right? Because we can't just click button in Dyna like you can do with Mechanical. We really need to understand what's going on. Okay, that's the two main thing to clarify because I think it's worth talking about. Giving an example model like this, right? Now, once we have the model set up, which we do, I didn't talk a lot more detail, but I talk about the two main talking points, right? About the two keywords I was using. Looking at the Dynain file, right? So I have to write the interface Spring Back LS-Dyna card to generate the Dynain file, which is essentially this card. Now you have to write this card to generate the Dynain file. The PSID99 is basically this node set, which is all the body included in the model. So what I'm doing with the interface Spring Back Dyna card is I'm going to write a pre-stress. I'm going to write all the stress data into the Dynain file. The F-type 3 here is going to generate a LSDA file, which is the file type that I'm going to be using for the case studies. Okay, so basically at the end of each stage, I'm going to write a Dynain file which summarizes the stress state of the entire model. Then I'm going to feed that stress state to the next stage of an analysis, which is why we need to have this interface Spring Back Dyna card. And once we have that, this is the basic keyword structure that we need to have, right? So a quick explanation of this thing is that uh, now, if you look at this keyword right here, right? So these right here, you see this test stage 1, test stage 2, 3, 4, 5 are the 5 different stages of an analysis that I'm going to write out. I'm going to demonstrate this in a second. And you can see in stage 1, I'm calling a geo file. This geo file is what I'm going to separate from the stage 1 of the analysis. And then for stage 2, 3, 4, 5, I'm going to call the corresponding Dynain file. For stage 2, I'm going to call the bulk preload Dynain file, which includes the bulk preload stress. For stage 3, 4, and 5, which is my XYZ accelerations, I'm gonna call the both preload and the gravity Dynain file, which include the stress state from stage 1 and stage 2. And these 5 different include files has a CID of 10, 20, 30, 40, and 50. These are the case ID file, which correspond to the case file right here, right? So over here, I basically indicated for each case which K file I'm including, and then I run these 5 cases sequentially from top down, right? So you're gonna run case 10 first, then 20, then 30, then 40, and 50. For each of these case number is going to include these corresponding K files to run an analysis, and that's in essence what a case file script look like, right? We're defining what file to include to run the case, and then we're defining the case sequence after that, right? So over here I define what happens in each case. Over here I defines the case that I'm running in sequence, and then that together is going to allow us run to or a batch script to generate a sequence of analysis from 10, 20, 30, 40 to 50, following these K file that we're including in the analysis. Okay. Now, let's do a quick example of what I'm doing here, right? So, for example, let's do like here. So once I have this model, this is gonna look pretty tricky, right? So you can see this thing right here, both preload happens in the first 0.05 second. Then acceleration, which is the gravity, happens in the from 0.05 to 0.1 second. Then the acceleration happens from 0.1 to 0.2 seconds, right? Or 0.1 to whatever termination time I indicate. So what I'm going to do here is I'm going to suppress everything except stage 1. I'm going to change the termination time to 0.05. And then I'm going to write this inside the example problem. I'm going to call this the demo. Demo. And then I'm going to call this the test stage 1. Let me make sure my name is right. My name should be, test stage 1.k file. All right, now for stage 2, I'm going to suppress this because I don't need to rerun the bolt preload because the stress will be included, and I'm gonna change to 0.1. And guess what? I'm gonna write an input file. I'm gonna call this the test stage 2. And then next, I'm gonna do 0.2. Guess what? I'm going to suppress my gravity load because I have the stress including the Dynain file, and I'm gonna do stage 3, which is acceleration, and then I'm gonna do stage 3. I don't know why it's not letting me audit. Okay, there we go. Suppress, unsuppress stage 4. Okay, now let's look at what I've essentially generated here, right? So I now have generated a file sequence called test stage 1, 2, 3, 4, 5. I'm sorry, it's right here, test stage 1, 2, 3, 4, 5. Now what I also need in this file is my main file, which is my case sequence, which is this file right here. Right, so what I'm gonna do here is I'm gonna go grab this file from my example folder. 1 second. I'm gonna go here. This is my pre-prepared model. Obviously, I'm just gonna copy this over. Now let's look at what's in here, right? So this is basically the same file as I've shown you guys. Over here, I have my test case 1, 2, 3, 4, 5. I have my test stage 1, 2, 3, 4, 5. Okay, and then the main keyword is called a case demo, and that's the job ID that I'm gonna be using. Now, what happens next is very awkward because we're at the mercy of the limitation of the Workbench LS-Dyna. But what we want to do next is that we want to be able to separate the nodes and the element data from the input file, such that because the node and element represents the geometry of the entire model, what I want to do is to separate out the geometry file from the entire model. And then I want to paste that into a separate file called test.geo, right? So let's generate a new file. I'm gonna call this LS-Dyna. I'm gonna copy this over, and I'm gonna call this file LS-Dyna. And I can explain how much I hate the Copilot, by the way. Since you're watching the video, maybe you care to know. Anyway, the end, and then over here I have the word keyword. Okay, I'm gonna save it. I'm gonna call this the test.geo. Okay. Okay, now this test.geo file is basically the geometry of the test stage 1, right? Because now without the test.geo, I have removed the entire geometry from this this model. This model now doesn't have any geometry, it doesn't have nodes or elements. I'm also this node right here is the remote point. I'm also adding that to the geo file because that's part of the node data, which is separated from the main file. And over here, right now this file right here doesn't have anything except for the boundary conditions and the control cards and so on and so forth. It does not have any geometry file. Now this test geometry is the one I'm going to include in stage 1. So you see in stage 1, I have test stage 1k and I have test GOK, right? And then guess what I'm going to do next? I'm going to do the same thing for 2, 3, 4, 5, except in this case, I won't be creating a new geo file because I'm going to be using the Dynain file to define the geometry because I have the stress state being written to the Dynain file, which is going to have the nodes and element data, right? Which means now all I have to do is to delete the nodes and elements from the test stage 2, 3, 4, 5, right? Now I also have to delete this remote point because this remote point is going to exist in the Dynain file, right? So when I call the Dynain file from the previous stage, it's going to have the stuff I just deleted, which is why we're deleting them. Because otherwise, you have a conflict. You basically have a duplicate node number, right? If you think about it. Same thing here. I'm just gonna go through the motion of actually demonstrating how to do this, right? So if you're following me along, hopefully this makes sense to you. Well, why we're doing this. Remember, if you don't do this, you will see an arrow telling you that you have duplicates, right? So that's why we're deleting them, because the Dynain file, again, the Dynain file has the information that the solver is looking for. That's why we're deleting these data, okay? And then obviously it's very good to have a text editor like VS Code to do the text file manipulations. It's not gonna be as easy with other things. And I'm gonna do note with other text editors. That's more standard. All right, that's the last of it. I think I may have forgot to delete a node on stage 3. So for the sake of actually doing good demonstrations, I'm gonna go check it. Yeah, I mean this took me a while to prep, so I remember what I needed to do, and what I usually forget because I have an extra node ID in the file that I didn't delete. There you go, you see that? I'm gonna delete this as well. Bam. Okay, now this is basically ready to solve, right? So now let's remember what we did. Stage 1, we are calling we're including the geo file that we separated out, as well as the stage 1 data, which is the bolt preload. In stage 2, we're gonna apply the gravity load, but we're including the Dynain file from stage 1. In stage 3, we're including the Dynain file from stage 2. And then stage 4 or 5 is the same thing. In the stage 4 or 5, because these are parallel, remember, these are the XYZ which are parallel, they all are calling the same Dynain file, even though they're solving in sequential order. 3, 4, and 5 is gonna use the pre-stress from 1 and 2 but not from each other, right? So which is what gives you that very awesome parallel path that were demonstrated earlier in here, right? This all is going to run in a single text file, okay, in a single job submission. So when you actually submit the job, what you can see here is that you will see something that look like this, right? So you can see that you'll be running with stage 1, 2, 3, 4, 5, and you will run sequentially. And then within the file itself, this takes way too long to run, so that's why I made a video of it to show. You can sort of see in here, I have the bolt gravity, which is my stage 2. Then I have my bolt itself, which is bolt preload, which is stage 1. Then I have my X load, which is stage 3. Then I have my Y load, which is my stage 4. Then I have my Z load, which is my stage 5. You can see all the D3 plots and such are separated out by a very clean file name. So you can actually post-process any of these stages, like what I'm about to show you, right? So this is stage 1, which all you have is the bolt preload. This is stage 2, where we're starting with the same stress state, and it's going to apply a gravity load to it, right? And in stage 3, it's going to take the pre-stress from 1 and 2, then apply an X direction, which is up and down, big acceleration, which in this case is actually going to break the bolts like that. It's stretching it because it's linear elastic, but it's actually gonna break the bolt in reality if I actually define the criteria for it. And then in this case, it's gonna be a y-axis, which is side to side. And you can sort of see it's going to do this, right? And then number 5 is going to be in z-axis, which is also side to side, just a different cutting plane. I can sort of see this is also going to do this, right? You can see all these 5 model are ran with exactly the same command, with the same single click of the solve, and it's run all with a file that look like this. Basically, this is the master file that governs the sequence of the case files. Each of the case file right here includes the pre-stressed Dynain file as well as the K file, which doesn't have geometry in it. It's gonna call the Dynain file. In the very first stage, we're separating the geometry file from the main file, so we call the main file and the geometry file, and together we can submit the case template 1.k file to the solver, and you will solve all 5 stages sequentially. Right, and that's the beauty of the case file, and you can apply this technique to any combination, any kind of large-scale DOE or optimization study you're doing, right? As long as you have the correct case file that you're using, this does a very good job of allowing you to submit a single job and run everything in sequence. And at the same time, it also gives you the option of looking at all of the stage results, very organized by very good file names, right? Very clear file names, so you know exactly which stage you are looking at. And that includes both the D3 plot, D3 dump, infer, anything that you want to write in database, you write out the information. So it's as if you're running 5 different analyses, right? Except in this case, you can see all 5 analyses happening sequentially, and they're all in the same working directory with a very clear file names. And that's why I believe this is a very good thing to demonstrate. It took me a while to organize this, but I feel like this is a very good technique to learn about LS-Dyna. That is a very useful thing to have. Okay, thank you very much.